Anybody else? I think that was the CIA. Anybody? They wouldn't be that blatant. We're looking at you now. Oh, okay. Anybody else have questions? Why do I have 15 people? There we go, 16 people. What is happening? Did I have a mass exodus? Do I suck that bad? It is possible. I suck. All right, let me see. Sorry, can you explain real quick how you got 0 and oh, sure. Yeah, I'll forget about this other thing I'm doing. All right, so again, this section of homework right here, this section right here, the whole idea of that section is concept. The first sentence in each problem is the most important sentence, and it's the sentence that a lot of people just skip. All right, so there's one idea that I didn't really talk about that I left for you to look up in the book, but we'll talk about it right now. Mutually exclusive things. Right? What does exclusive mean? When I say exclusive, what do you guys think of? I feel like I shouldn't record.
Not inclusive?
I love you. True. Define something by its opposite. No, that's not a good idea. Somebody's chatting at me. Excluded. Okay, sure. If some place is exclusive, what does that mean?
Means only certain people can get in.
Yeah, it excludes people, for example, right? So mutually exclusive means you don't let me in and I don't let you in, nah. So they don't share anything, right? It's like a rock and ice cream. Can you be a rock and be ice cream at the same time?
No.
No, I used to use dogs and cats, and then there was a cartoon that was on TV for a while. I don't know if you guys know about Cat Dog. So I had to come up with, I use rocks and ice cream. That seems to be good. And somebody's like, well, I have ice cream that looks like a rock. And I'm like, it's not a rock then.
Cat Dog was brilliant.
Yes, as long as you didn't think too much about the biology. Now, so mutually exclusive means two events that don't overlap at all. So if A and B are mutually exclusive, that means the probability of A and B is 0. So for example, what could you immediately, well, which one do I want to do? I'll do this one. What would you immediately write after reading this sentence? What can you immediately write as true? After reading this sentence here.
A and B.
There's no A and B here.
One event can't happen without the other.
Okay, so if A and B are mutually exclusive, I know that this is true, right? True. I don't want words. I don't want words. They've already given me words. Look at these words. Oh my God.
I and F.
Sorry? Say again. Sorry.
E parentheses I and F.
E and F? Okay.
E and F, I'm sorry.
Sorry.
Equals 0.
Yes, right? If I know two events are mutually exclusive, I know the probability of both of them happening at the same time is 0. I can immediately write that down. Now, they tell me this, and then they ask me this. All right, what's the formula for probability of A given B? What's that formula?
A plus B divided by B.
It's not A plus B. I think I know what you mean, but be careful because it doesn't mean add.
A multiplied by B?
No.
A and B?
A and B. There we go. Okay. right, let me stop for a minute. We actually kind of developed this formula. We created this formula based on something we did. We could actually see what the formula must be to kind of jive with what we know is true. So pretty cool with what's happening so far. There's nothing I've written down here that's like new, except for maybe this, but that's in the book. Okay. Now, is anybody concerned that there's E and F here and there's A and B there? Who gives a shit? What's probably of E given F then? Just using exactly what this formula sets up for me. It's probably E given F.
0.
No. We haven't shown that yet. We haven't proven that yet. What is the probability E given F in formula form so then I can actually plug stuff in?
Probability of E and F
Yes.
divided by probability of F.
Yes, please tell me that you understand that A and B, those letters, there's not a damn magic thing about them. There's nothing magic about X. There's nothing magic about Y. Those are just the two letters algebra chose to use most often. Who gives a shit? Didn't we start using other stuff, other letters in algebra? Because they're actually called dummy variables. They're just placeholders. So A and B are like X and Y. A and B are like probabilities X and Y. Are you guys with me so far a little bit? They're just the letters they chose to kind of use most often, right? But so what does this formula then tell me? The probability of one thing given the other thing is the probability of one and the other divided by probability of the other. It just sets up what I always do no matter what those things are. So probably given F is probably E and F divided by probability of F. Do you guys all get that? That is how you use the formulas we developed, even though other problems don't have the letters A and B, right? Is that all right? You guys doing all right? You guys hate me even more now? Okay, every day this guy sucks a little more. All right. Now, why did somebody say 0? Because what did we write here? We know that the probability of E and F is 0. So couldn't we plug a 0 in right there? So this is 0 divided by what? What's probably an F? 0.5.
0.5.
I like it. So you get 0. Bam. Now, why does this make sense? Listen. If two things are mutually exclusive, like rock and ice cream, right? All right, stay with me. If I go into a room and there are 10 rocks and 10 bowls of ice cream, you with me? 10 rocks, 10 bowls of ice cream. I reach out and I pick up one thing. What's the probability it's a rock? There's 10 rocks, 10 bowls of ice cream, right? I reach out. I'm blindfolded. I should say that. I reach out, I pick up one thing. What's the probability I just picked up a rock? I love you guys so much. You're probably trying to make this more complicated.
50%.
Would it be 10 out of 20?
10 out of 20, exactly, because there's 10 rocks, 10 bowls of ice cream. So what's probably I get a rock? 10 chances to get a rock out of 20
0.5.
total things. Is that cool?
Yeah.
That is the fundamental idea of probability. Now, what if I take my blindfold off and I see that it's a bowl of ice cream? What's the probability that it's a rock then? I love you guys.
0.
Thinking is 0, exactly. There's a 0 chance. So when I reach out, pick something up, I got blindfold on. I can't tell. It could be a rock or ice cream. So I'm like, it's a 50% chance it's a rock. But I take my blindfold off. Given that it's ice cream, the probability it's a rock is now 0. Now, I love you guys because you're all out there going, well, of course. Yeah, of course. Well, of course. That's why this answer makes complete sense. If they are mutually exclusive, if one of them happens, what's the chance that the other one happened at the same time? 0. It can't happen because they can't happen at the same time. All right, maybe, you guys. Maybe. So of course it's kind of like a silly example, it kind of shows why the answer is definitely 0. It only makes sense that it's going to be a 0 chance. All right, so what about if I told you, I'm going to erase all this. You guys ready?
Wait, screenshot.
Sure.
Oh,
I don't know if all this chicken scratch is going to mean anything to you, but yeah, okay. You ready?
got it.
All right.
Got it.
What if I tell you that A and B are independent? What does that mean? What can I write down? What must be true if they're independent?
One does not affect the other.
True. Now less words. What's probably of A given B have to be then?
Probability of A.
Yes, B will not affect A. B happened and A said, I don't care. Just like that. I don't care. All right. So if they tell me in a problem that two things are independent, I can immediately write this down. I can also write this down. What does this have to be?
Probability of B.
Yeah. So one happening will not affect the other. One happening will not affect the other. That's what independent means. So does everybody understand now that these first sentences in each of these problems are the most important part of the problem? Without those, it's impossible to answer their question. So don't just pass those by and go, all right, words, here's the problem. No, words mean something. Okay. All right. Sorry, somebody sent me a message. Anything else about this section here, or does somebody have a different question from somewhere else? Okay, so let me do something real quick. So again, if I'm you, if you haven't really started this chapter 3 homework yet, something you really want to have next to you is all the formulas, right? What's the probability of A or B? What's that formula?
Probability of A plus probability of B minus probability of A and B.
Yes, cool. I like it. And what about probability of A given B? We already had this one up here.
Probability A and B divided by B.
Probably B. Okay. My poor little B has been out in the sun too long. Get out of there. Right? These are nothing new. We've written this down. It's just good to have these all in one place. And probably of A and B, this is the one that is confusing, I understand. We're not used to having multiple ways, multiple formulas that mean the same thing, but
B multiply A given B.
B given A,
B given A. Yeah.
or probability of B times probability of A given B. Yeah, so you'll see in problems, you're like, well, which one do I use? Well, you use the one that you have enough information about. Isn't that cool? There will be a problem that you have to pick the right way to do it based on what information you're told. So these would be excellent idea to have these sitting next to you while you're doing your homework. And of course, while you're doing the homework, you can use notes, right? It's crazy. You can't use notes when you do a quiz, right? You can't do that. So if you better stop, because that's shit. You're gonna die on the midterm if you are using notes. Yes, and I'm sorry, you just won't. Not literally. I hope not. But you will not do well on the midterm if you are doing quizzes with your notes, because that means what you know is not what you know. It's on paper. You don't know shit. All right. Okay. Anything else from here before we move on? Okay. Gotta stop sharing. Everybody ready? Gotta stop sharing. Oh, I gotta do this too. Shit. Hold on. I always forget to do this. There I am. It's all about me. All right, guys. Anything else before we get back into? We're actually going to get into chapter 4 because we're crazy. Yeah. Yeah, we are. We're all crazy. Do you guys remember? So right now there's a quiz happening, correct? In fact, I've got to make sure that none of you are actually taking the quiz right now, because that would be bad. All right, nobody's taking the quiz right now. Good. I'll keep an eye on that. There's a quiz happening right now, but in a 6-week class, you got to be aware, when's our next quiz happening?
Tuesday? No,
Monday.
Monday.
Yeah, quiz 3 is on June 28th, which is Monday. Holy shit. It's almost like we're in a 6-week class. Now, that's why I set the due dates for the chapter 3 homework the way I did. I've already had a few people turn in chapter 3 homework, so I've been grading those as I've seen them come in. Just to show you here. So of course, here's where you see that. And then of course, look at this beautifulness. You ready? The midterm is July 1st. Excusez-moi. Oh well, that's the way it goes. Let me think. What was I going to show you? I completely forgot. I totally forgot. That's too bad. I took too long. Dadgummit. I do have the practice quiz up here, right, for chapter 3. And I just made this available so you can see the answers. So you can kind of double check. But what some of you guys might be interested in, because not all of you taking the quiz, is kind of going over these 3 things here, right? Standard deviations worksheet, the 2.1 through 2.6 practice, because standard deviations is 2.7. So together they cover all of chapter 2. So that's the stuff that's on the quiz is happening right now. All right. I haven't graded any of those quizzes yet. Just because. I'm going to grade them tonight and tomorrow morning. Okay. All right. Let me think. There was something else I was going to show you, and I completely forgot what the hell it is. Sounds about right, Jeff. All right. Even when I was younger, I had no memory. Okay, so if there is nothing else, is there anything else from chapter 3 homework that anybody is working on currently that's not making sense? Or how about chapter 2 even? Because some of you guys haven't done that quiz yet. Does anyone have anything left over from chapter 2? All right. All right. Hopefully that means good things. I'm an optimistic fool. So I'll pretend like that means everything's fine. Okay. So if there's nothing, I'm going to go into chapter 4. And I'm going to first show you why I chose that backdrop, because I just chose to have this shirt on today. It's my what I call my Death Starry night shirt. All right. So we're leaving chapter 3 behind already. It's like we barely knew it. And we're going to get into chapter 4 today. So let me get things set up. Of course, I didn't do that earlier because I'm crazy. Hold on. Oh. All right, let's see if I can turn off my Death Star. That's no moon. Come on, you can do it. Okay, so I'm kind of going slow because I don't quite believe there's no questions, and I guess I'm going to have to accept that there's no questions. All right. So let's get into chapter 4. So chapter 4 is our first introduction to another way of giving you data. And it's actually not our first introduction. We sort of have done this before, but not so blatantly. So what we're getting into is, all right, let me try to say this. Throughout this semester, a little 6-week thing, we are going to be given data in different ways. There's going to be different distributions, different ways to give us data. What are the two most important numbers to get from any data set? What are two most important kind of numbers to calculate from any data set?
Mean and standard deviation.
Exactly. You gotta excuse me. I'm just having a little death here. Hold on. 0 to 1. I'm not sure what that means. 0 to 1. So the mean and the standard deviation. So when I'm given data in a different form, as a math person, I'm always looking for the quickest way to do anything. I'm sure a lot of you guys are probably the same way with other things. So I want to see if they give me data in a different form, is there a quicker way to calculate the mean and the standard deviation? Okay, so let me see, how do I say this? Oh, all right, let me do this. Okay, here we go. Ow. I know, hold on. All right. So what I want to work up towards is we're working towards being able to do this kind of problem. Not 0.7, Jeff. Blah, 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 blah. All right. This is another way to give me data. And what this would mean is 19.27% of the data points was 4. 23.51% of the data points was 5. So isn't this basically just a relative frequency table? Do you guys understand what I mean when I say that? Isn't relative frequency the percentage of how many times this thing showed up, which is also the probability, because probabilities are basically related to percentages, right? If 30% of you hate the color purple, then the probability I pick somebody who hates the color purple is 30%. All right. Now, so I'm gonna slowly work up the way to how to do this mathematically using a much simpler example. Okay, and whenever I do that, I always have at least one person say, why is he doing it this way? This is harder than it needs to be. And I love that shit so much. So what I'm doing again is I'm going to take an easier example to build up a method that will work for this harder example. All right, so let me stop saying what I'm going to do and I'll just do it. Here we go. So let's keep this to the side. So let's say I have this data here. What do you got, Jeff? I got 1, 1, 2, 3, 3, 3, 3. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I like it. There you go. Jeff's showing off again. He can count. Now, let me make my standard plea real quick. I appreciate everybody who's able to turn their camera on. If anybody else can, that'd be great. Just so I feel like I'm talking to other humans. If you can't, I understand. You're fine. So, all right, how would you guys just calculate the average here? How would you do it? Somebody just tell me, how would you get the average of this data? What would you do?
Add and divide.
Yeah, it's crazy. Add them all up and divide by 10, right? Because there's 10 data points. So let me start to do that. Oh, there's 2 1s. Can't I do this? Is this all right? Somebody think I'm being tricky here? And there's just 2 1s. plus 1, 2, plus 4 3s. Are you guys all cool with this? Am I doing anything tricky? And of course, I haven't done what yet? I've got to also divide. I'm not doing anything tricky. So you guys are like, you're a math teacher, you're always doing something tricky. Go ahead. Hold on, let me do this real quick. Why is this not working? All right, it's a little better. I'm trying to make this a little easier to read. All right. Now, I could, what is this? 2 plus 2 is 4, plus 12 and 12 is 28. Is that right? 28 divided by 10, is that what you guys get? Does that sound right? I'm going to pretend like it is. So I get an average of 2.8. Don't forget, we're not just trying to get the average. We're trying to create a process that works in a different situation. So that's why I'm not going to just stop here. So this is the old way to do it. If I'm given a list like this. Help me out here. Can I, mathematically, is it okay for me to go 2 divided by 10 is 0.2? Plus 1 divided by 10 is 0.1. Does anybody have a problem with me doing this?
No.
Not a damn problem. Good. That's the right way to be. Not just because I'm the teacher or some shit, because it's true, right? As long as I divide each thing by 10, then I'm fine. And in fact, I get the exact same answer. But what does this 0.2 mean physically? How many ones were there? There were 2. What percentage of my data was ones? What percentage of my data is 1?
20%.
20%. 20% of my data is 1. 10% is 2. 40% is 3, and 30% is 4. Yes? Do you see the connection now? No? So, and of course, if I do this, I get 0.2 plus 0.2 plus 1.2 plus 1.2, which is still 2.8, which is still the right answer. Of course it is. Wait, I don't hear any dissension, which means, let me make a slightly less evil problem here to talk about. All right, so now I've got a way to do this. So let me see, what was this? How can I represent these? What's the one letter I can use to represent what these are?
X.
X, good. So isn't this X? And then what's this? Uh-oh, let's see. What were each of these we just said a minute ago? Sorry? Aren't those the percentages, the probabilities? Right? Because what's the probability you would pick a 1? 20%. So what each of these is X times P of X. Isn't each of these X times P of X? And of course, what did we do? We added them up. That is the formula for the mean when I am given data as X's and probability of X's. All right, so let's try another problem. I'll let you absorb that for a minute. So I just want you to see, this is what the math, so this is the old way to do it. This is another way we could do it. Would I ever necessarily do it this way if I just had this? Hell no. So why did we do it this way? Just to see what other way we could do it. And then we have this situation where I'm like, oh, thank God. This makes it so much easier. So if I'm given this, all right, I'm gonna do this so it's not so hard on my no, Jeff. Really, Jeff? It happened. Okay, all right. I love it. Somebody out there must be like, oh man, Jeff's had a rough pandemic. I think he's even before this, I would talk to myself. So don't.
I was just about to ask that question if being on Zoom made you talk to yourself more, or
You can look at some of my old videos. I'll talk to myself in class. Jeff, what are you doing, Jeff? People would joke me about it, but I'm perfectly sane.
I do it all the time when I'm working.
There you go. Now I'm kind of going a little slowly here. What do you think I'm being careful about? Anybody? So you had to really go slow.
The sum,
Yes, what's the sum got to be?
1.
1.
The sum of the probabilities has to be 1. Is it okay if it's 0.9999?
Yes.
Yes, good, because there could be some rounding or shit, but you know, these are only 2 decimal places. So sure enough, if you add those up, what do you get?
One.
1. Check.
And if it's over 1 because of rounding, that's still acceptable, correct?
Yes, exactly. It could be 0.9999 or it could be 1.0001. But if you get like 1.07, that's really bad. You have 7% extra stuff. It's like, no, that's not good. That's not a rounding problem. That's just a problem. Okay. I'm gonna erase this, okay? I need some more room here. You guys, this is old shit. We don't need this anymore. Old shit. Get out of here, old shit. All right. There's my little formula. I'm gonna put him over here. Get over there. By the way, real quick. Stay with me. What was do you guys remember the little tiny original formula we had for the mean? It was like the first time we saw the sum symbol, right? So you remember you add up all the
X.
x's and divide by the number of them, right? The only real difference between these two, there's no over n here, correct? Stay with this is so cool. Or at least it's cool to me. And I'm a math teacher, so who knows what the shit I think is cool. What's on the bottom of probabilities? By definition, what's always in the denominator of a probability?
All the values.
All the possible things, correct? The total number of things, which is n. So isn't this have an over n in it? Does anyone understand what I'm saying? Don't probabilities build n in underneath them? Doesn't it have an over n built in? So these are the same damn formula. Oh yeah. If you don't quite get what I'm saying there, it's okay. It's not the end of the world. But the probabilities have an n in them underneath, so that they're the same form. So what does the formula tell me to do? Well, if I cover the sum symbol, I've got to do x times p of x. I've got to make a column of those. So of course, what does that mean here? Where my x is at here, where my p of x is at here. So how do I make a bunch of x p of x's? Anybody? What goes here? Zoom.
2 times point.
Yeah, 2 times. Yeah, just do multiply across. 2 times 0.11, 0.22. 3 times 0.52. 1.56, I believe. 4 times 0.23. Nobody's going to help you, Jeff. It's okay. 5 times 0.14.
0.7.
Okay. And then how do I get the mean? I've got a bunch of xp of x's, and now what do I do with them all? What does the formula say? Once I got the xp of x's, what do I do with all of them?
Add them.
Add them. Yeah. So the mean is going to be the sum of these. So let's add these up. Become a 5 again. What do you when you add those up? I don't know. Is it 3.3? Did I do that too fast?
3.4.
3.4?
3.4.
Okay, I'm sorry. I did it too fast. I like it. Now, real quick question. What would the average of 2, 3, 4, and 5? What's the average of 2, 3, 4, 5? Would it be 3.5? You guys agree with me?
Yeah.
Why did this come out less than 3.5? Where's most of the data? What data point occurred the most?
3.
3. In fact, another way I could say it is 3 is the heaviest weighted piece of data. These are like weights. 50% of my data is 3, so it's the heaviest weighted thing. So it's going to drag the mean closer to it. It's sort of like a gravitational pull. Does that make any sense? So it's almost symmetric, sort of. I mean, it's small, goes up, goes down, but the center is moved a little bit, so that's why that's 3.4. It's a little bit less. So if 2 had been the heaviest weighted, it would have been even less. It would have been pulled up towards 2. Do you have to know all this, what I'm saying? No. We got the answer. So shut up, Jeff. Okay. So what do I still need to figure out, though? What did we say earlier? What are the 2?
Standard deviation.
Standard deviation. I love it. All right. Nothing else. Stay with me. What's going to happen is I'm going to write down just what's required, and then I'm going to create a quicker way to do it. Okay. So I'm going to write some stuff down that we're going to erase in a minute, but just to get us started. Now, I want you to understand, when I try to find the mean, I can't just add these up, right? I've got to first multiply by the weight, and then I add them up, correct? Sure, okay. I'm just gonna say that. So, and what's the formula, what's the old formula for standard deviation? Let's say variance. It's this. You guys remember that? Remember this little thing? Yeah, maybe. No. Never seen it before? I don't know what you're talking about, Jeff. Okay, all right.
Oh, that's the formula we were using to eliminate negative numbers.
Yeah, the reason the square is there is to kill the negative numbers. The formula is all about finding the average distance from the mean to the data points, but one step in that was squaring to kill the negative numbers, exactly. Now, I don't know if you guys are going to fully follow me in this, but remember how this has an n underneath it? And remember, so it's not really there, Jeff, don't worry. And remember how I just said you have to multiply what I want to average times the weight, right? So I need to take, now this is what I'm going to erase, so don't even write this down. I would need to figure out x minus the mean and then square it and then multiply it by the probability. And then I can, so the new formula for this would be the sum of x minus the mean squared times p of x. I really want that to make some kind of sense. Remember how p of x has an n underneath it? And see how there's an n underneath that? So if I just write times p of x, I don't need the over n anymore. It's built in. I multiply.
My question is, when would you rather use the old formula or the new formula?
Oh,
You know when to choose either or.
so watch this. I would use the new formula if I have the stuff that's in the new formula, right? If I just have a list of data, why would I use some new ass formula? I don't need to. But if they give me data and with x's and p of x's, I'm going to use the formula that's got x's and p of x's in it. Does that make sense?
Yeah.
Okay, I like it. I mean, it really is that simple. If I have formulas, if I have a problem where they give me x's and p of x's, I probably want to use a formula that's got x's and p of x's in it. Now, we're not going to use this. Oh my God, that would so suck. That's just too much shit.
The new formula says the sum of x, and then what is the thing next to the x?
Same thing, yeah. So it's x minus the mean. It's the same thing because it's at the heart of it. I'm trying to average these. So that's why I multiply by the weights, just like we did earlier. Okay. Now, so the way you want to do your notes is we're going to come back and add something in here. We're going to have one more column here. But for right now, I'm going to go to the back side. We're going to do a little algebra. You guys are like, man, come on, I need some algebra. All right, so I'm going to go to the other side. All Oh, I remember this. All right. So let me ask you guys. We're not going to do this whole thing out, trust me. We're just going to do the first couple steps so you maybe buy into it. So here's the formula that I wrote down. Is everybody cool with that? I really want you guys to understand there's an over and in here. So this is the same formula as the old one. They're the same formula. It's just reorganized to work better with this other way to give me data. Now, put your algebra brains in for a minute or whatever. Wait, put your algebra socks on. I don't know what this shit. If you saw this piece in an algebra class, what would you do to it to simplify it? Somebody, please.
Standard order operations.
Not really.
Okay.
Anybody?
I would
He's on
summary-
square root.
Can't take a square root. It's not a formula. It's not an equation. It's not equal to 10 or something. So I can't
I
take
would-
a square root.
I would put each, like, I would take parenthesis x minus mu and then put it next to another x minus mu.
Yes. Yes. And then you would do what with this? Somebody else.
First,
Foil it
outside,
out.
inside, last. Foil.
Multiply it out. You would foil it, right? Now, I'm not going to go into my big rant about why I hate foil and it shouldn't exist. And I don't mean foil that you put on a baked potato. I just mean the foil method is bullshit. But doesn't matter. Doesn't matter. I don't care what you call it. We know what to do. So help me out. It's just repeated distribution, right? The x gets a turn to distribute, and then the little mu dude gets a turn to distribute. So now stay with me. I don't know if anybody's worried. You're not going to have to do this kind of thing yourself on some other weird looking thing. No, this is not an algebra class, but we will use algebra when we are deriving things for sure. Not driving, deriving, right? Okay, now. Guys, go ahead and do it. I'm not going to do it with you. Go ahead. Don't say anything. Foil that bad boy out. Multiply that bad boy out. There we go. All right, somebody help me out. What do you guys get?
X squared
X squared. I like it.
minus 2x mu.
Good. So you're going to get minus x mu and then another minus x mu. So you get a couple of x mu's.
Plus 2 mu.
Good. Well, no.
No?
Mu times mu is.
Oh, that's right. Okay, sorry.
That's right. You can let it go.
A little rusty.
Understood. But do you guys follow that? If it's been a while, do you remember that? Foiling stuff out like this at all? No? Okay. Looks like I'm rocking a mullet. Jeez, I gotta get some help. Now, there's a lot of steps I'm not gonna go over. In fact, I mean, if you're curious, I think I have this written up on a sheet of paper. We're not gonna go through the whole summation algebra, okay? But I want you to buy into where this goes eventually. So if I plug this in, I get this. Is that cool? We figured out what this was, so I just plugged it in. And then what would you do with this bad boy?
Distribute it.
Yeah. So the very first thing you would get would be the sum of x squared p of x minus other shit, right? Now, if anybody's curious, I can show you how this works. I'm not going to do it right now because this is not the point of this class. But if you follow through the algebra, the really weird thing. Does everybody understand what I mean by this? Because I would have to distribute there, distribute other shit. If you do the math to the other shit, it ends up being this. So here, and I understand if you don't believe me, but of course, I can prove it. I just want to admit it. So what the shit, Jeff? What the shit? Was that all just so you can get your algebra in here? Algebra boy? Sort of. But we've got what I am claiming is a better formula to get the standard deviation. This is the variance, of course, and I take a square root. Is that all right? I haven't taken the square root yet. So I'm going to turn the page here. Is that all right? You guys ready? Anybody still copying? Okay, here we go. So instead of needing to build all of this crap up, now that I know the formula is this, get in there. Now that I know the formula is this, I want you to understand. What do I need one more column. If I cover this up, I need a column of x squared times p of x. Do you guys see that? Remember, you cover up the summation symbol and you go, oh, I need a bunch of these. I need a bunch of this shit. So I need one more column, x squared times p of x. Yes, that's the new formula. That's the one we're going to use. Because I got to make x p of x to get the mean. And now I just got to have x squared p of x. Now, does somebody have a suggestion on how to make x squared p of x? What would I do in this row, for example, to make x squared p of x? What could I do? We call this L1, L2, L3, L4, right? Because you could actually do all this in your graphing calculator if you want to, right?
Would you just,
Say again?
sorry. I was just gonna say square L1 and then multiply it by L2.
Good. But what I normally do, now that's perfectly fine. Not a damn thing wrong with what you're saying at all. But here's what I do. Again, I'm weird. You don't have to do this. So you could do L1 squared times L2. Or you could do L1 times L3.
What is this giving us in words?
So again, you got to follow. Here's the formula. Any questions on that? That's what we developed back here. That's the formula. And once we got the formula, we say, okay, formula, what do you need from me? And he can't talk. I'm like, shit. So I got to reach out. I got to cover that summation symbol, and then I see what I need. I need a bunch of x squared p of x's. Are you with me? See, this has come up. I told you earlier that we're going to see the summation symbol quite often. So anytime I see a summation symbol in a formula, I cover it and I say, I need a bunch of those. Right? That's why we did this. So then I can add them up. So I need a bunch of those. So then I can add them up, and then I can throw that answer in there and I can figure out what the variance is. We stop for a minute. So I don't know if you picked up on this, but what kind of really sucks for students about this class is that it is concept heavy. There's not a lot of algebra at all, but there is still quite a bit of variable manipulation and calculations, right? So you got concepts and you got some variables and you got a lot of calculations. So if I do L1 times L3, because I can do that up here on the board pretty easily. 2 times 0.22 is 0.44. Real quick, do you guys understand what is x times x p of x? What is x times p of x? What is that? What is x times p of x?
0.44.
No. In general, no numbers. What is x times x times p of x? X squared p of x, which is exactly what I want, correct? Okay. So now I go 3 times 1.56. I believe that's 4.68. Is it?
Yeah, that's correct.
It's correct. Sweet. And then 4 times 0.92. What's that, smart boy? I don't know. I think it's 3.
6.8.
Oh, I was going to get there. And then 5 times 0.7. That's too easy. So this column, if I add it up, I get the mean, because that's exactly the formula for the mean. This column, if I add it up, I get the number that I put into this formula to figure out the variance. You guys with me? The sum of this is just a piece of that formula there, right? So unfortunately, we're not frickin' done when we add those numbers up. It's like, damn it, math. Get to the point. So somebody help me out. What do you get when you add all these up? Because that's what I need to do. I need to add them all up. Want me to do it? Shit. 6.
12.3.
0.3.
12.3, I like it. So the sum of x squared p of x is 12.3. And that needs to go right here, correct? You see that? The formula needs that sum right there. So I'm like, all right, formula, let's see, 12.3 minus the mean. And the mistake people make is they forget to square that. Now, one thing I want you to remember, can you all say this to yourself? I have known about this formula for less than 30 minutes, right? So I am not expecting you to feel fully comfortable with this yet. You just heard about this damn thing like 10 minutes ago. So kind of get off your own back a little bit. It's okay. It's going to be all right. But hopefully you followed a little bit about how we got the formula. Then you can see, okay, this is how you parse any formula. You cover the sum symbol and you say, okay, I need a bunch of x squared p of x's so I can add them up. All right, bam. And then when you add them up, you put the number in the right place. Right here, 12.3 minus the mean squared. Now what the hell is that? Don't make me do that in my head. I don't want to.
0.74.
What is it?
0.74.
0.74? Okay, that makes sense. Yeah, that makes sense. So then what's the standard deviation then? What's sigma? What do you have to do, of course?
Square root it.
Square root. 0.8.
0.8602.
Okay, I appreciate that. That's cool. Go out 4 places. Now think about this. Why does it make sense that the standard deviation is so small? Standard deviation is less than 1. Over half of my data points are what number?
3.
3, good. 52% of my data points is 3. The mean is 3.4. So over half of my data points is 0.4 away from the mean. You guys with me? So of course the standard deviation could come out pretty damn small when over half of your stuff is sitting right on top of the damn thing. Right? Another 23% is only 0.6 away from the mean. So I mean, it's kind of neat that it wasn't even smaller than that. All right, sorry. Awesome. All right. Now, I don't know. You're probably going to be surprised. You're like, what, Jeff? Oh, wait. Samantha, you're clapping and raising your hand. I love it. What's up?
Oh, I lost on the last part. Why Number. Why? Why is that number?
Why is that number? What do you mean? So
Yes.
so are you cool with this?
Yeah.
Yes? You're cool with this?
Yes.
Okay. Then you have to square root, right? To kill the square. So do this.
Oh, okay. Thank you.
And what's really weird is when it's a very small number, square rooting it makes it bigger. Just like when it's a very small number, between 0 and 1, multiplying makes it smaller, so square rooting makes it bigger. It's definitely weird. Yes, you can. I'm sorry. Yeah, totally. Go for it. Somebody's chatting at me saying, can I take a picture of it? I'm taking a picture of it right now. Samantha, what's up? Do you have another question, or did you forget to put your hand down? Are you okay? All right, okay. All right, now, what was I about to say? Did I get to my punchline for my dumb joke? I don't know. You might be amazed to find out that I have a worksheet. That was my fantastic joke. Yes, I know. I won't quit my day job. Try to become a comedian or something. It's not going to go well for me. All right. Oh, I feel like I need a booster seat. So if we look on Canvas, I might not have made this active yet. Here we go. So if you go, if you go to Canvas right now, or if you refresh, I guess if you're already in there, if you go down to Unit 4, by the way, doesn't it feel like we just met and we're already in Chapter 4? I know, it's the way it goes in 6 weeks. So you should see this in Unit 4, probability distribution. So I really want this to make a lot of sense. Remember when I said earlier, these are kind of like relative frequency distributions. And then I said a relative frequency is a percentage, which is what a probability is. So therefore it makes sense. We're going to call these probability distributions. So if you click on this bad boy, let's take a look at this. So maybe not surprisingly, it's not going to load for me. I don't know what. Why does my own Canvas hate me? I don't get it.
It's not loading for me either.
That sucks. Let me see. Can I download it? Where am I at? Oh, I am there. Yay, it downloads. That's good. That's useful. Is anyone able to open it? I'm gonna have to figure that out.
I opened it.
You did?
Yeah, I got it on my phone though.
Mine's on my iPad, so.
I'm only able to download it.
Okay, no worries. I'm on the same boat. I think it's more a Canvas problem than it is our problem, but that's what I'm gonna say anyway. So let's take a look at this. So not surprisingly, I've got a completely worked out problem, right? Completely worked out. And then I have a side where I want you to work on it, right? So I think today, I don't care how you feel about it, I am gonna put you in breakout rooms just because we haven't done it in a while, right? So you can sit there with other people that don't talk to you and you're like, what the shit? By the way, if that happens to you, you can just call me in. When I put you in breakout rooms, you know how to hit the call for the whatever the dude's name is to come in, right? You can call me in. All right, so what I want you guys to do is you can use this side as kind of a guide. And you see how I put up here, if you want to put this into your calculator and do it in the lists, you totally can, right? Totally. So I even put that up here. So I need you to do this side now. This exciting thing. Sorry. That was
Oh, yay. I won those.
okay. Oh, I know. I gotta do this.
There we go.
All right. Oh, this is gonna be exciting. I think I have this stuff in here. Let's see. Is that the stuff? Yeah. This is gonna be weird for me because I can't see my calculator to do this. It sucks. Now, if I want to, I don't have to do this in my calculator. And this is blurry again, isn't it? Hold on. Hold on, guys. All right, now, so if I want to do this, I can go up to L3. I can do L1. Make sure you guys can see what I'm doing. L1 times L2. Is that what that says? I have no idea.
Right. And then how do we get that to sum?
All right, hold on. I'm gonna
Right,
make
sorry.
Okay. And then I don't know if you guys can really see that too well. Hold on. Ooh, all right. That's better, right? And then I can do L4 and I can make it become L1 times L3. Hopefully that's what that says. I don't know. Okay. Does that look familiar? Those, well, hold on. Those numbers look familiar? What's wrong? Come on, focus. This thing won't focus anymore.
Those look good.
Okay, think. Now, Billy's question is, how do I get the sum? Because we got to get the sum of L3. That'll be the mean. And then I get to the sum of L4, and that'll be what I throw in to get the standard deviation, right?
Yeah.
So if I hit second quit, and then, wait, hold on, am I spotlit? No, you make it all about me. There we go. All about.
What happened to your camera that you could just like set the thing on the desk and do it from there?
No, I could. I actually, all right, so here's what I have. See this? I'm just being lazy.
Yeah.
I don't want to move it over so I can turn it around and put it down here.
Oh, okay.
Let me be lazy. So now hit second quit, come out of there. Then I can hit second stat to go to list, right? I want to do something with my lists. I want to do math on my lists. I want to sum up. So I'm going to hit number 5 because number 5 says sum. What do I want to sum up? I want to sum up L3, for example, right? That's my mean. Is that what you guys got for the mean? I know one group
Yes.
did because
Yes.
they called me in. Okay. And then, now watch what I can do. Watch what I can do. I can just hit second, enter. It brings this back up, and then I can just go back and make this freaking L4. So I don't have to go all the way back through freaking lists and freaking, you know. So there's my sum of x squared p of x. Is that what you guys got there? Does that look familiar?
Yes.
Yes. Okay. I'll lock it. Now, coming back. Sorry. No, I'm going to be blurry. You ready? Oh, that. This captures
Wait, what was the sum on L4? I didn't get that.
2410.89.
2410.89.
Yes.
What did I do wrong?
I don't know.
And B was 96% or 0.96.
Wait, what? Wait, no, we haven't done. All I did was fill in the table. That's all I've done.
Okay.
I haven't done anything else yet. Okay, so coming back to the handout. And Jordan, I don't know. Real quick, did your list 4 have 17.64, 150, 368?
I had the same numbers on your lists.
Okay.
Those look right, but maybe I just added them probably wrong on the calculator.
Okay. So let me put this down here for us. Get over here. So our mean, the sum of this came out to be 45.89. This little dude came out to be 2410.89. Why is this a valid probability distribution? Is it a valid probability distribution?
Yes.
Yes. Why?
The numbers add up to 1 in the P of,
Careful. What numbers?
the P of X column.
Okay. All P of X's add to 1, or you can just write sum of P of X equals 1.
And each must be between 0 and 1.
Yeah, and don't say must be, because then it sounds like you're not checking it. Say each P of X is between 0 and 1. Or you can say 0 less equal P of X less equal to 1. Cool. So this needs to be you checking it, right? Don't tell me what must happen, tell me what did happen. All right, so this is valid because all the probabilities add to 1 and they're all between 0 and 1. And some of you guys might be like, why do I have to say both of that shit? Because if I had this, do these probabilities add up to be 1? Do these add up to be 1? They
Yes.
totally do, right? Is this valid?
Yes.
No.
No.
So now you understand why you have to say two things, right? What's the other thing this definitely totally goes against?
Above
It
1.
can't be below 0.
Freaking negative probability. What does that mean? What are my chances of passing a negative 20%? Like, that's an evil thing for somebody to say, right? Or what's my probability chance? 150%. What does that mean? You're going to pass so hard, you're going to pass 50% of your next class. It's like, damn, that's awesome. It's like paying a little bit of your next year tax. I don't know. Are you guys okay out there? So I can make something meet one of those requirements, but if it doesn't meet both, it's not valid. Okay. This was just a straight up, can you just read this thing correctly? So what's probably a kid picked, believes they'll be at least 25 when they retire. So what's that probability?
96.
How'd you get it?
I added all the numbers from 25 to 100. I mean, well, all the
I'm with you.
numbers in LTO
I'm with you.
0.24 to 0.02.
Beautiful. Did
So if
somebody
it was
have
on, if it was on a graph, it would just be I'd start at that point and take all the numbers above that.
and did somebody have a quicker way to do it?
You could do 1 minus 0.04.
Yeah. So you could totally add these up. That's beautiful. That's exactly what the problem's asking for. Or you could do 1 minus this because that's the only thing that it leaves out. Either way, you get 96%, right?
Mm-hmm.
That's kind of related to that at least one thing that we did yesterday. So 96% chance that we get a kid who thinks they'll be at least 25. These 4%, I'm worried about them. They're going to face the harsh reality. They can't all be Zuckerbergs, which actually is good. I don't want too many of them. Anyway, I don't know. We already know what the mean is. It's 45.89. We don't know what the variance is at all, but I know that this piece of the formula is 2410.89 minus what?
1.
45.89 squared.
Yes. What's the formula say? It says minus the mean squared, and the mean is 45.89. Yeah. So I don't know. I didn't even do that. I don't have a clue what that is. What do you guys get?
304.10 or 99.
And then the square root of that stuff.
17.464.
Chickens the acid. I like it. And that kind of makes sense. Aren't these, if I just had to look at these real quick and guess, I'd say like 20. I don't know if anybody agrees. I'm like, how spread out are these numbers from the middle? I don't know, about 20 on average. So 17 makes sense. It's on average how far away the numbers got from the middle. The fact that they're weighted differently would change that. You can't exactly eyeball it, but still. This is going to sound very familiar, but we can't do it the way we did before. So the mean is in the middle. I'm going to go up one step. So if you add 17 to that, you get like 63 something, right?
0.354.
And if you subtract 17, blah, blah, blah from that, you get
28.43.
28 point stuff. Okay. So which data points did we catch between 28 and 63?
40 and 50.
40 and 50. What percentage of the data is 40s?
23%.
Good. So now you understand the way to do this. You caught all the 40s and you caught all the 50s. Well, all the 40s is 23%, and all the 50s is 18%. So what total amount of data did we catch?
41%.
Kicking ass. I like it. Okay. Now this one's a little bit weird. It's like a two-step process. We know there's 1,200 total kids. If we just knew the percentage that thought they would retire before age 65, this would be easy. But we do know the percentage. What percentage think they'll retire before 65?
29.
No, that's the percentage that think they'll retire at 65.
69%.
Good. If you add all these up, right? Or if you do 1 minus 31%, you get 69%. So then you do 69% of 1,200. And you get whatever the hell that is.
828.
Sweet. 828 kids think they'll retire before age 65. Of course, retirement age will probably be 70, 75 by the time they get up there. Okay, again, somebody's asking me, I think I'm behind on this, but you seriously have to help me out because I will forget. Just send me an email, say, can you upload the last few answer sheets? Math boy. And I'll say, geez, all right. Any questions on this here? Okay, thank you. All right. I just want to say real quick, we are going to do a little bit in section 4.3. We basically, I don't know if you guys noticed, this is 4.1 and 4.2 that we did. Let me ask you guys a really strange question related to car insurance. Is there anything magical about age 25? Does anybody know? Has anyone hit that age yet?
It goes down.
Yeah, so the minute you hit 25, the morning of your 25th birthday, you suddenly know how to drive correctly. It's crazy. So when you turn 25, your insurance goes down. Does anyone have any clue why that's true? Because what I just said is not true.
Averages.
The amount of accidents that happen for people under the age of 25.
So you can set up, all right, this is related to some of the homework too. You can set up this kind of table for like amounts of money you think you'll have to pay out and the probabilities of having to pay that money out. And that's dependent on age. Because younger people tend to get into more accidents, right? And so do older people, by the way, right? And so do in-between people. But on average, the probability of a younger person getting into an accident less than 25 years old is higher than above 25 years old. It just is. So the insurance company says, let's charge those people more, right? Does anyone get a good student discount? You guys even know that's possible for a lot of insurances? I did. Yeah, little geek I am. I sent that sucker in. I'm like, ooh, even less money. I really want you to understand this. I could set up a table, how much money we might have to spend and the probability of those kind of things happening. And I could figure out the average amount of money I'd have to, as an insurance company, I would have to pay to cover somebody's car. And then what would I do? I would want to charge people more than that so that I can make sure that I come out ahead. I make a profit. Are you guys with me? I'm not saying, do you like this method? I'm just saying, are you with me? Now, they'll do a table like this for different ages. And it's been discovered that about 25 is where people's probabilities start to go down significantly or significant enough. Anyway, so that's a little side note about what the shit is this good for, Jeff. I understand that question. Okay. Stay with me now. We're going to do just a little bit of 4.3. We'll finish up 4.3 tomorrow. We're going to do a little bit right now. I know it's already 3:30 and you're all spoiled. All right. What's funny is I was about to say, I really want this to make sense, but that's basically, I always want things to make sense. So it's not a special thing about this section. So this is section 4.3. And do you guys remember when we had that little discussion about, I can't remember what it was, we were picking like marbles out of a bag, and I said, somebody asked something about the order I was asking them in. Do you guys remember that? When it was blue, red, green, and then red. And somebody's like, what about the order? And I'm like, oh, what's gonna come up? And that day is today. So I know, well, let's pretend that, do I want to do that? Yeah, why not? So 11% of Americans are left-handed. And I will tell you this, I will double check that. The last time I saw any real data on this, it was 11%. I don't know if it's been updated. How many, anybody here left-handed? I'm not gonna put my hand up. Anybody left-handed?
I am.
This one? Anybody else?
Ambidextrous.
Ooh, ambidextrous, watch out. I'd give my left arm to be ambidextrous. Jeez. Good, I'm glad somebody got that. Technically ambi, all right, so yeah, okay. I was just curious. 3 out of 23 is like 14, let me think, like 12, 13% or something. That's roughly the same, that's crazy. I could be totally wrong, it could be, anyway. So 11% of Americans are left-handed. Let's pick 5 Americans at random. Jeff, my God, dude. Random. What's the probability that exactly 1 is left-handed? All right, I really want you to, can anybody see? Do you see the difference between this question and the questions we had like this before? Out of the 5 people, which one, I lined them against the wall, which one of them does this problem want to be left-handed? Does it say?
11%.
No, stop. We know that 11% of all Americans are left-handed. We know that. That's a known thing. I get 5 people and I line them against the wall. Does the problem tell me which person is going to be left-handed? Which person do they want left-handed?
Exactly 1.
It only says exactly 1. Could it be the first one? Yes. Could it be the second one instead?
Yes.
Yes. Could it be the third? Okay, we get it, Jeff. So, is there more than one lineup that would meet what this problem wants?
Yes.
Yes.
Wait, why isn't it just 0.11 times 5?
So many reasons why not.
Okay.
All right. So like if I said, real quick, if I said not left-handed, isn't that 89%? Yes? Right? If 11% are left-handed, what percentage are not left-handed?
89%.
Good. And if I pick 5 of them, 5 times 0.89 is bigger than 1, correct? That's a problem. All right, so maybe I should do this. Do that problem. If I said, what's the probability of the first one is left-handed and last 4 not left-handed? And why do I not say right-handed? Because it could be ambidextrous. They could be somebody who was born with no hands. So I always have students that are like, oh, what about the other? I'm like, it's in there. It's in there. I'm just going to say left-handed, not left-handed. Bam. Everybody's in there. Everybody's included. This one is like the problems we did before. I can make my little hangman game. Hangman game. What goes here for sure? What do I want the first person to be?
Left-handed.
Left-handed.
What's here? What's the
0.11.
probability? 0.11, and then the rest I want to be not left-handed. So what goes here?
0.89.
0.89. So ready with me? 11% left-handed. So I want the first one to be left-handed. 11% chance. What's the chances the other four are right? Or I'm sorry, not left-handed. 89 each one. Remember, you could also write this as 0.11 times 0.89 to the fourth. Remember that? You can put a 1 there, right? There's 1 left-handed, 4 not left-handed, but in a specific order, correct? And then you just throw the old calculator and get something, whatever the shit. So 0.06. So, I don't know.
Okay, what formula applied to the first to get 11%? Because we just went through a ton of formulas today.
11% was information that I gave you.
Okay, sorry.
I like it. So the problem has got to give us some information, and that was something I just gave you, right? Okay. So this is old news. We've done this. Anybody do it? What do you get when you do it?
0.0690.
690, okay. Now, new stuff. Not completely new, but still new. So now I have 11% Americans left-handed. We pick 5 Americans. And now I just wanted to probably exactly 1. And so this is less specific. Do you guys agree? This is less specific. So there's more than one way to match what this wants. Okay, now watch. So one way to do it is exactly this way, isn't it? So let me see. Left-handed, and then a not 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 left-handed, correct? Are you guys with me?
Mm-hmm.
So this one would be the first one's left-handed, and the other 4 aren't. Or, what's another way to do this?
Do NL and N.
NLNN. Or NNLNN. Or NNNLN. Or, no, I've really gone NNNNL. Crap. You guys okay with that? You guys, this is not too hard. You just float the L through. Is that cool? Sorry. I'm sorry.
It looks like an eye chart.
What's that? It does look like an art chart. You're right. Okay. No. Stay with me. You go to the doctor, you're gonna be like, when you see that letter, what letter is it? Now, look. I'm obviously. Are you guys cool with the fact? Isn't this the first one's left-handed and the second one's not left-handed and right? That's why we multiplied up here, isn't it? What do I do for or? What does or mean?
Adam.
Adam. So each one of these, what would math say about L times N times N times N times? It's like, what are you doing, you silly person? Wouldn't I write that as L times N to the 4th? Yes. Yes. Isn't that sort of like what we're on here?
Yes.
And you're going to add them. So I've got L n to the 4th plus L n to the 4th plus blah, blah, blah. I'm going to add all these up together, correct? And how many do I have? What do I end up with? How many of these do I have? 5 times L times N to the 4th. And I really should have, well, it's okay, Jeff. It'll be fun. It doesn't matter. Okay. I'm assuming L means the probability of left-handed. That would have been nice to put down there too. So where does 5 come from? It came from the total number of ways to do this. I don't know if you understand how big that list can get. Has anyone ever heard about if you have a pizza and you have like 13 different toppings, how many different pizzas can you make? And I might have given the wrong number of times. It's like 7 million or 13 million or something. It's insane. It's way more than a normal human would consider. Stay with me now. So now, just to do this real quick, could I put this in my calculator now? 5 times 0.11 times 0.89 to the fourth. Yes, we can do that now. This was neat. I think you get 0.345, right?
Yeah. Yep. Perfectly.
Neato. Little fringe benefit. So what am I saying? So here's what I'm saying. Oh, real quick. So this number came from how long this list is. Where'd that exponent come from? And where'd that exponent come from? Why does it make sense from the beginning that these are the exponents on each of these?
Because there's 4 of those.
Say again?
There's 4 of those.
I have 4 not left-handed because I have 1 that is left-handed. That makes sense, right? So the exponents are how I broke up the 5 people, yes?
I'm confused how you got 0.345 because I got 0.435.
All right, I don't know. You plug in 5 times 0.11 times 0.89 to the fourth. What, Jesus, Jeff. Make sure you put a point in there. Yeah, I got 345. I don't know, I don't know what's happening to you here. 5 times 0.11 times 0.99 to the fourth.
Oh, I put squared. Derp.
Okay. No. So, for example, all right. Let me see. I don't want to say this. So let's do the same situation, but let me. This is a little bit sloppy. This notation here. I want something that I can make a formula for that works in any situation. What if I don't have left and not left-handed? What if I have some other situation with different letters? No. Let's make it the same letter. So I'm going to call P. Lowercase p is going to be my probability of success. And the success is whatever we're looking for. So in this case, a success would have been a left-handed person, right? So a success could be a dead person. It could be a rabid squirrel. It could be a sunken ship. Success doesn't have to be happy. It's just what matches what we're looking for. So Q is the probability of failure, which is just something that doesn't match what we're looking for. Okay, so this is a little thing I want to put here. So instead of putting L and N, I could have put P, Q, 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 and then Q, P, Q, 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 right? And the P and the Q are always the same letter for any situation. All right, now, what if I had the same thing? So I still have 11% of Americans left-handed. Right, so that means P is 0.11 and Q is 0.89. Is everybody with me? But now let's say I pick 45 Americans. What's the probability that, what do you got, Jeff? Exactly, get in there, stop it. Exactly 5 are left-handed. Does somebody understand that if you ask me to make a list like this for that situation, I am going to leave. I'm going to say goodbye. Do you understand how long it would take to make this kind of a list for that situation? Do you guys begin to understand? I have 45 people. who could be the left-handed people? Maybe the first 5, maybe the last 5, maybe the middle 5, maybe the first one and the last 4, maybe the first 2 and the middle one and the last 2 or whatever the shit. You guys with me? You guys understand? How long would that freaking list be? It would be stupid long. Sorry, it'd be really, really long. Do you guys understand that at all? I would have 45. Yeah. I think some of you guys can tell. Okay. But so I don't know the number. I don't know this number. Why was this number so easy? Because the list was easy. It was small. It was a small list, so I knew it was 5. So I don't know this number. But what do I know here? Like, yeah, sure. You're gonna be. How many 0.11s do I want? We know that. What's the exponent going to be on 0.11? That's a left-handed person, right? So how many of them do I want?
5.
5. Doesn't the problem say you want 5 left-handed people? So I want 5 of these. So how many of these do I want?
40.
40, because I have 45 people. So what do the exponents always have to add to be? It has to add to be the total number of people. I like it. So just in case anybody's still a little lost, it could be like the first 5 are P's and the others are Q's. Or maybe it's the first 3 are P's and then I have some Q's and then I have the other 2 P's and then I have Q's. And blah, blah, blah. But what's the same in every single one of these? I have 5 P's and freaking 40 Q's, every single one of them. That's exactly why the exponents are so nice. The exponents match up with how many you're putting in each category. It's crazy. So all we need is how long would this list be? That's the number I want to put there. If only we had a piece of technology whose main reason for existing is working with numbers. Oh yeah, we do. All right. So let me show you. I don't know if you're with me or not. I don't know if you're with me with the exponents. This part of this problem is really simple. We can always do this ourselves. We just need help with, I don't want to make that list. Do you want to make this list? If you think you do, you're wrong. You are very wrong. You don't want to make this list. So is anybody curious how long that list would be? Does anyone understand what that question means? So maybe I should have, screw it. I'm still gonna be lazy. All right, so how do we do this on the old calculator? Hey, calculator. Hey, I can see it.
Hello, everybody.
Sorry, let me turn them on. See many Jeebus. Mouse, wake up. Focus. There we go. All right, now, oh, this is better. Okay. There's a really kick-ass function in this calculator. Now, let me say, I didn't say this, but can you consider, like in this problem, I have 45 people. And don't you want to choose 5 of them? Wouldn't that make sense? I want to choose 5 of them to be left-handed. So there's a function. So let's type in here 45. All right. Then here's a very intriguing button. I don't know if anybody's pressed the math button. I don't know if you're worried what's going to happen. Well, let's press the math button and look at this weird shit we get. We can convert things to fractions and we can do stuff in cube roots and some calculus. Something that looks like what we need right now is probability. And this one right here is choose. It actually stands for combinations, but I just like the fact that it's the letter C, so I call it choose. Right? And this one is National Public Radio, in case you want to listen to them. It's a joke, sorry. So if I hit choose, 45, choose 5. So what this means is if I have 45 people, how many ways can I choose 5 of them? Are you guys with me? All right, let's see how long. This is how long the list would be. What is that? That is
Wait,
a million.
How do we get to math again?
I'll show you. All right, let me do it again. In fact, let's do this. Hit 5. There's the math button right there. There's the math button.
Oh, it says math.
Math, go to
Probability.
probability. And then number 3, the choose one. 5, choose one. So this is like the first problem we did. I had 5 people. I wanted exactly one left-handed person, right? And remember, we got a 5. Our list was 5 big, and there you go. The list is 5 big. This list would be 1.2 million long. Do you understand? Do you understand? Okay. So like if I had 13 toppings and I wanted to choose, screw it, I'm not gonna do it. All right. We don't have time for that, Jeff. Oh wait, I want to do more on the calculator, you crazy person. Now, my formula, shit, I want to do everything. All right, come here, you. Let's go old school. Yeah, buddy. All right. So what we got so far is the probability of, so I'm given a situation where I have n things. In this case, I have 45 people, right? I'm given a probability of success. I'm given and then I can figure out the probability of failure. You guys all with me out there? So I very often call these problems NPQ problems, which is crazy. They are technically called binomial problems. What's the word bi mean?
Two.
Yeah, the prefix bi means 2, right? So this is like 2 possibilities. Isn't this broken up into 2 categories? Left-handed, not left-handed. Right? So binomial probability means you have a probability of one thing and a probability of something else. 2 possible outcomes. There it is. So what is this formula? Well, it's going to be.
What does a Q stand for?
What does the P stand for?
Probability of success.
Good. So what's Q have to stand for? It's the opposite.
Probability of failure.
Tickets. So this is going to be N choose X. That tells me how long the list is. P to the X. Does that make sense so far? If I want X successes, that means I want. Are you guys cool with that? That's just what we were talking about earlier about the exponents have to match up. So I want X successes. Now here, can somebody figure out how many failures do I want then? How many failures must there be?
N minus X.
N minus X. I love it. That's the one that looks a little bit wonky. But if you think about it, that's exactly how you guys figured out to put a 40 up here on that last thing we did. Okay, so you can't really see that, can you? Screw it. I'm too lazy to work. So I think we've got, so this situation is P is 0.11, Q is 0.89. What else you got, Jeff? N was 45, and I want to have 5 successes. Jeff, so the probability of 5 successes is 45 choose 5 times 0.11 to the 5th times 0.89 to the 40th. Let me stop for a minute. I really want you guys to get the fact that the formula makes this last thing seem worse than it really is. It's just, the formula's just got to be really weird, because if I take X away from N, then I have N minus X left. Well, that's weird. Well, here, if there's 5 people here, 45 total, of course there's 40 people here. You guys semi with me out there? You guys really hating your life now? Like, good Lord, I thought this was bad.
Yeah.
And then today happened. All right. And now I just got to throw this all in my calculator. So here's how I throw it in the calculator. Calculator. So I'll put 45. I'm going to put it all in there at once, so I don't get any freaky shit. Math, probability, Jeff, 3. 45, choose 5. Times 0.11 to the 5th. Push over, times 0.89 to the 40th. Kabammo. There's a 0.1860, so 18.6% chance that there will be exactly 5 left-handed people in a group of 45. Woo! All right. Oh, is everybody cool with that? You guys got that?
Wait, on this calculator, how do you get it to do exponents again? I know I'm asking redundant questions and I apologize.
That's all right. There's your to the button right there. The arrow.
Oh, duh.
Yeah, so if I do 7 to the 8th power, there's your to the button. Bam.
I keep getting error. I don't know.
You sure you
why.
got point? You sure you got 0.11 and 0.89?
Yeah. It's all, I don't know. Hold on, let me unplug it. Okay, let's see if.
So hold on. I'll let there. Just keep it there. Hold on. Oh wait, there we go. Oh.
No, I tried like clicking over like you
I know
said.
exactly what's going on. Don't worry. Notice how your 11 and 8 are tiny?
Yeah, that's, I don't know how to.
No, you never came up. So let me type this in again.
Okay.
45.
Okay, 45.
Choose 5. Now, see how there's a little arrow? I am
Yeah.
down right now. I am
Yeah.
I'm in the subscript. I've got to hit the arrow button.
Oh, okay.
The same thing happens on the
Oh.
component. I've
See,
got to hit the over arrow.
Yeah, okay. Because every time I clicked over, I thought when it went up, I thought it was going into like the exponent. So I was like going back. Does that make sense? I don't know. It just
45
seemed like this.
math.
Right.
Choose.
That makes sense.
5. Yeah.
Okay.
Choose
5.
5. Hit the over arrow. Now, some of you guys, do you have calculators that said 45 NCR 5?
Yeah, that's what mine says.
Beautiful. You don't have to worry about the hit the over arrow bullshit. You just keep going. Times 0.11 to the 5th times 0.89 to the 40th. Bambo. All right. All right, my God. I think that's
Hey,
enough.
how do we get back down once we go up?
You hit the over arrow.
Yeah, but it's keeping me in the exponents.
All right, let me catch up to you.
It's
So
giving me an exponent 5 times.
now look, right now, right after you hit 5, you have to hit the over arrow. That's what it's telling you to do. Hit the over arrow so you come back down.
Got you.
So anytime you're in a subscript, you got to hit the over arrow, come back up. Anytime you're in a superscript in a exponent, you got to hit the over arrow. All right, guys, I think that's enough. What do you guys think?
Not until I get it.
All right, I'm sorry. I need to stop. I'm so tired. Okay.
Okay.
That's enough for today, everybody. The first day we almost stayed the whole time. It's crazy. Let me know if you need to hang out. Otherwise, get out of here, and I'll see y'all tomorrow. Don't forget about the quiz. Do the quiz. If you haven't done the quiz yet, do the quiz.
All right. Jeff, how did we get 11 in this situation? The 0.11. Sorry to fry you.
No, they have to give me something, right?
So they gave you the 0.11.
Yeah, see, 11% of Americans are left-handed, so I knew that was 0.11. Now, in real life, we have to actually go do a survey and kind of estimate that, right? But here, they're just going to tell me what that is. Everybody else okay? What's going on out there? You guys okay out there?
It's NCR 5 up, and then, sorry, I can't see. But, 11 up 5. Duh. 11. Let me get this.
So what's happening out there? You doing okay? What's going on? Are you?
Yeah, I just keep entering it in wrong. I'm just getting used to the calculator.
Yeah.
$45. Choose 5. Choose 5 times 11.
0.11.
0.11 up 5 over parentheses 0.89 parentheses up 40 and over. Enter.
Show it to me before you do it. Show me your calculator. Okay, let me hold on. Give me a second.
Put some light on it.
Hold on.
Use.
All right. You got the answer. You're fine.
Cool. Okay. Thanks, man. I'll see you at 12:45 tomorrow.
Okay. Take it easy, man.
All right. You're the man. I really appreciate you.
Sure.
All right. Have a good day.
You too.